Problem 2 from the AP free response questions packet that I gave you deals with some velocity functions, acceleration for one part, and then to start this off, we're looking at position functions to write out here. So the information given to us tells us that a particle P is moving along the x-axis. The velocity of particle P at time t is given by this function v sub p of t is equal to sine of t to the 1.5. From t going from 0 to pi inclusive. At time t equals 0, particle P is at position 5. Then they mention a second particle Q. We're given the velocity function denoted by v sub q of t. And then at time t equals 0, particle Q is at position x equals 10. So for part A, we're asked to find the positions of particles P and Q at time t equals 1. And we're definitely going to use our calculator here. You may even want to start by defining. You could call it V of t if you want to. You can say V, maybe V1. You could use different variables as well, as long as you understand what they're representing on your calculator. So you could define V1 of t to equal sine of, you could use t to the 1.5 or you could use x's. And then you could define V2 of t to equal t minus 1.8 times 1.25 to the power of t. So you could define those two functions. That way, if we need to use them, we can. All right, so one thing the graders are going to want to see is that for positions, we'll call them x, since they're using x here, we'll say x sub p of t is going to equal, that's going to be the position. So right now, the position at time t equals 0 is already starting at 5. So we need to keep that 5, and then we're going to add how it's going to move. So then we want to add the integral from 0 to 1, because we're just going at time t equals 1. So we have to go from 0 to 1 of, we'll say v1 of t, and you could do dt. And you could just pick the v sub 1 and then put in a t, and then after the d put a t. Just make sure you go from 0 to 1. You can type all that in on your calculator. And then that should give you about a 5.371 when we round to 3 decimal places. And then we could do x sub q of t. That's going to start at 10. And then we're going to add however this is moving. So this again would be from 0 to 1. This would be v2 of t dt. So you'd want to go ahead and type that in. And this should turn out to be 8.564. So you get 1 point total for the two integrals, 1 point for each final answer. And it wouldn't hurt to just write this out as well, so you could just kind of summarize and say at time t equals 1, the position of particle P is 5.371 and Q is 8.564. So there's 3 points just for part A. Let's take a look at B. Are particles P and Q moving toward each other or away from each other at time t equals 1? So again, we're going to go back to the velocity, because if velocity is positive, that means our particle is moving to the right. Negative, our particle is moving to the left. So let's just figure out, we'll do V, and just use the notation as we go to write this out, V sub P of 1. We'll go ahead and calculate that. So all you have to do is go back to the variable key, choose V1, and then just hit 1. So that is equal to 0.841, which is greater than 0. And then we'll do the same thing, VQ of 1. So go back to the variable key, choose V2, and then just type in a 1. That's equal to -1. So it's less than 0. But we also need to know where the two particles are with respect to each other. So we're going to go back to the positions. So we know that X sub P of 1, that was the from part A, that was 5.37, and then Q was at 8.564. So particle P is to the left of particle Q. So X sub P of 1 is less than X sub Q of 1. So particle P is to the left of Q at time t equals 1. And P is moving to the right. Q is moving to the left, at time t equals 1. Therefore, the particles are moving toward each other. So let's see how the points were here. So you get 2 points, one for the direction of motion for one particle, and then an answer with explanation. So we'll just say you get 2 points for all of this. All right, let's take a look at C. Find the acceleration of particle Q at time t equals 1. Then we need to answer, is the speed of particle Q increasing or decreasing at time t equals 1? So if you recall, acceleration, and this is of Q, is going to equal the derivative of the velocity function. So now we're going to go back to our calculator. We just need to find the velocity, or the derivative of the velocity. So go back to, we're going to go find, hit menu for 1. We're going to use t here. Remember, we defined our function in terms of t. So it's d over dt, and then just go to the variable key v2 of t. And you get a rather long one, so we're going to define this answer that we get. So once you get this expression, just go back to menu, define, let's call this a of t. All you have to do is go back and click on that big expression that you get, and then just hit enter. So now we defined a of t. But again, this is key that they want to see this part. Now all you have to do is go back to the variable key, hit a of 1, and you should get a 1.027. So you get 1 point combined here. So it's the setup and the acceleration. Now this next question, it's actually going back, I don't know if you guys remember how we had the rocket launching and then a parachute popped out. It was a problem from a while ago that we analyzed the graph of this. We could kind of go back to here, but there's just a fact also to help us consider this. If a speed is increasing or decreasing depends on the sign. So this part here, we want to compare the signs of velocity and acceleration at time t equals 1. So we know the velocity of particle Q at time t equals 1 was negative, and here our acceleration of particle Q at time t equals 1 is positive. So when the signs are opposite, our particle would be decreasing, or the speed of the particle would be decreasing. You get the other point for that. So just 2 points for part C. Now let's take a look at D. All right, this one, this is why I mentioned on that handout that I gave you of the facts. Just go to that fact, what was it, 36? I think it was 37. The total distance traveled, because we're allowed to use our calculator, is just going to be the integral. This time we're going from 0 to pi, but it's going to be the absolute value of our velocity function, and that's going to be of p dt. So all you have to do on your calculator is type this in. So menu 4.1. Again, type t. I'm sorry, menu 4.3. And we're going from 0 to pi. And go back to your variable key. We want v1 of t. Actually, before that, to type in the absolute values. So this is what you want to do. 0 to pi, type in abs, and then type in v1 of t dt. And you should be getting a 1.931. So you get 1 point just for setting it up and 1 point for the answer. And part D, yes, is that simple, but the hardest part was remembering what formula to use, what integral to use.